Uh, Phenols, as you know, this is the second chapter from the organic chemistry, and we start from the phenol, okay? And as you know, phenol is benzene ring, tamam, benzene ring, and substituted with what? With hydroxyl group, okay? This hydroxyl group has unshape of electron, two couples of unshape of electron, okay? Make the phenol compound is slightly what? Basic as nucleophile. This can be work as nucleophile, or is acidic to give you a proton as bromistid acid. Okay, this is the phenol, and we have here resonance. We have the benzene ring, and so the chemistry of phenol is coming from the OH, the hydroxyl group that has acidic proton and has what? Unshape of electron. Okay, so as introduction, phenol compound, also known as phenolic, okay, are a class of aromatic compound characterized by one or more hydroxyl group that directly bonded to what? To the benzene ring. Okay, not short, it is not yani beta, it will be one cycle of benzene, maybe two cycle of benzene, three cycle of benzene. Okay, it must be aromatic compound. Okay, so this now, this is naphthalene, okay? And if you have here hydroxyl group, this hydroxyl group will be phenolic on the naphthalene. It will be naphthol, okay? So now this is what? Aromatic compound, yes? Aromatic compound, phenol. But if you have like that compound, for example, this is phenol? No, this aromatic compound, yes, aromatic. We have aromatic ring. But this, the hydroxyl group, is bonded to the sp3 carbon. It is not sp2. It is not aromatic carbon. That meaning this is not phenol. This alcohol. Okay, alcohol. Primary, secondary, tertiary, any alcohol this? Yes, it is a primary alcohol. Okay, so you have to be careful about that. Okay. This general information about phenol. Phenol compounds are widely used, distributed in nature according to the plants, microorganisms, and even some animal products. Okay, naturally occurring of phenol play important roles in plant defense, accumulation, and growth regulation. Okay, so while synthesis phenol are key intermediate in the manufacture. Okay, بتجيلك مهمة for the manufacturers, pharmaceutical, dyes, plastic, resin, and agriculture, أسمدة الحيوانية. Okay, so due to their antioxidant and antimicrobial, it is, we talk about the biological activity. So phenol can be work important role as drug. Okay, as a drug for many medicines and medicine fields. This about general information about phenol. Okay, now we come to the nomenclature of the phenol. How we can give name for the phenol compound. He said, look, the phenol is come from the phene. Phene, it is the old name of the benzene cycle, phene. For this name, because we have OH on the phene, it will be phenol. Phenol. Okay. So, like many other compounds, we have our IUPAC system. Okay, we have our IUPAC system, and always we go with IUPAC system to give the name of the compounds. Also, we have common name, but if you use the IUPAC system, it is the better for you. Also, we have the common names. For this reason, if you have like this compound, for example, number 1, this is phenol, yes? And this, do you remember? This, don't look to here. Grisor, this is also can be used as IUPAC name, but this is phenol, okay? Methyl phenol, okay? Or reverse, it will be meta-hydroxy-toluene. Also, this is the IUPAC name, okay? But the metagresor, it also can be used as IUPAC name. Can be used as IUPAC name. And I also explained for you here the meaning. Okay. Now, if you have more than 2 substituents like this, orthometa para can be used for the more 2 substituent? No. Ortho, meta, para cannot be used if you have more than two substituents. Okay, you will be used numbers. Okay, will be used number. For this reason, yes, this is methyl, phenyl. This is the metaglycerol. But here you cannot say meta. This it be metachloro ortho, ortho methyl. No, cannot be used this system. Okay, for this reason, you have to put 1, 2, 3, 4 like this. You have to put number. Always, the hydroxyl group take number 1. Okay, always the hydroxyl group take number 1 and proceed to give the second substituent lower number. Okay, so anyone is best 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5? 1, 2. Okay, that meaning it will be 2 methyl and we have 5 chloro. Okay, alphabeticals, the substituent, when you write the name, it will be 5 chloro, 2 methyl phenol. Okay, it's difficult? No, our IOPAC system. So, there are dihydroxy derivative of benzene may be named by 1, 2, 1, 3, 1, 4. This 1, 2, dihydroxybenzene. Okay, this 1, 3, dihydroxybenzene. Okay, this is the name of this compound. It will be named like 1, 2 benzene, benzene, 1, 2 diol. Diol. That meaning you have 2 hydroxyl group. Okay, diol. This 1, 3 benzene diol. This 1, 4. Look, 1, 4 benzene diol. Okay, the common name. Okay, the common name for this compound is pyrocatechol. Okay, this is the common name. Okay, this resorcinol and this hydroquinone. Okay, this is the common name. Common name matlub. Okay, it's matlub. Okay, matlub. You have to save the names. Okay, matlub. Okay, but in your exam, if I give you this compound, you can choose. You have to write the IOPAC name or the common as you want. Okay, يعني according to the question. If I say to you, give IOPAC name to this compound, خلاص IOPAC names. Okay, what's your question? Orthopara? Okay, he said, can be used orthopara for this compound? Okay, if you go to the root, to use the root. Okay, what is the root? The root, that meaning this is what? Phenol. And this is hydroxyl group. That meaning if this, it will be ortho hydroxyphenol. Okay, can be used. Okay, if you write note for you. This is what? Meta-hydroxyphenol and this para-hydroxyphenol. Okay, you can use it. Yeah, it is not false. It's right. Tamam? Clear for you this? Okay. The common name for 2-hydroxyl, this, it is from the naphthalene. This without hydroxyl group, the name is naphthalene compound. Okay, naphthalene compound. Okay, and he said the common name for the 2-hydroxy derivative of naphthalene, this is the naphthalene. Okay, without hydroxyl group, is the naphthalene. Okay, R1 naphthol. Naphthalene or OH hydroxyl group هاتية. Okay, it will be naphthol. That means it will be 1 naphthol. And this, it will be 2 naphthol. This take number 1. 1, 2, 3, 4. If you write number as you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. Okay? This for the, and can be acceptable as IOPAC name. خلاص, as IOPAC name. 1 naphthol, IOPAC name. Okay, 2 naphthol, IOPAC name. Okay. This homework for you, you have to resolve the homework. As I told you, you have 1 week when the chapters will be finished to receive the homework from you. Okay? So, phenol resonance. Okay, phenol resonance, I think you know the resonance. I don't go to explain the resonance for you again. Okay? But we said, what meaning the resonance? It is same arrangement for the atoms, yeah, and sigma bond. Okay, the different, where is the different? In pi bond and the unshape of electron, the position of the pi bond and the unshape of electron. Okay, the range of the atom, it will be the same. So if you have like phenol, like, okay, this 1, 2 unshapophilic. Where is the resonance? It will be started from what? From the move, yes, from the move of the unshapophilic electron, okay? It will be moved to make pi bond, and this pi bond between oxygen and carbon, it will be formed. The weak bond pi, it will be open to this carbon, okay? It will be give you what? Minus on the carbon. That means it will be give you anion, okay? It is anion, minus. Okay, not carbocation, give you carbon negative, okay? So, it will be this. Negative, like that, okay? And the oxygen will be what? Positively charged, okay? It will be positively charged. Why positively charged? Lost the electron, the oxygen lost the electron, that means it will be positively charged. Okay, the total charge here is what? 0, here 0, خلاص, okay? يعني it is impossible, this it will be مثلا 0 and this it will be minus. Impossible, هذا خلط, okay? It is wrong, you have wrong here, okay? So, the second resonance structure, this can make pi bond and this open to here, okay? And as I show you here, I don't write it again because it's easier. Maybe I give you small question in your exam, write the resonance structure from the phenol compound, okay? For the phenol compound. You have to write this, okay? This 1, 2, 3, okay. Now, here on the cycle of the benzene cycle, it will be pair negative charge, negative charge, negative charge, negative charge. That meaning hydroxyl group is donating or withdrawing? Like a negative charge? Donating or withdrawing? Electron density here increase or decrease? Look, the electron density here, negative charge, is increase or decrease? Huh? No, my question, increase the electron density or decrease? No. Increase the electron density, minus electron density, okay? That meaning the OH here is donating, okay? Donating by an effect, the two effect here. Inductive effect or resonance. This by what? Resonance, طبعا, of course resonance, okay? So you have to be careful here. The hydroxyl group is donating by what? By resonance. Tamam? Clear? No question? Okay. Many of properties of phenol, look, many properties of phenol reflect from the polarization employed by the resonance description, okay? The hydroxyl oxygen is less basic and the hydroxyl proton more acidic, okay? That meaning he said this is less basic, weak base, and the proton here is more acidic. Tamam? Okay. Now, look to the resonance structure. Why the phenol is less why the phenol is less basic than amines? Why? For example, why? Or less basic than alcohol? Why? Why? Because the resonance. Okay, the resonance make what? Give me the good answer. Look, this unshapophilic electron is busy with resonance structure or not busy with resonance structure? Busy. That meaning the unshapophilic electron delocalized over benzene ring. Okay? That means the unshapophilic electron is not ready to attack the proton. Okay? For this reason, is less basic than alcohol. Okay? It's less basic than alcohol. Why? Because the unshapophilic electron is delocalized over the benzene ring and it is not ready to attack with the acid. Okay, to reaction with the acid. You understand? Okay. For this reason, he said here, the hydroxyl oxygen is less basic, and the hydroxyl proton, the proton, is more acidic. More acidic than what? And what? Than what? Than alcohol. Than alcohol. Okay, question for you. Why the phenol is more acidic than alcohol? Okay, if you have two compounds, alcohol and phenol, anyone is more acidic than other. To تجيب خطوة أولي, what you have to do the first step? to write the conjugated base. Write the conjugated base. Second step, compare the stability of the conjugated base. Any one is more stable than other. Okay? For this reason, if you have alcohol like that, CH3, OH, okay, and you have phenol, OH, anyone is more acidic, first step, write the conjugated base, our conjugated base. Okay. We have resonance here? No, that meaning this is what? Less stable. Okay. You have resonance here? Yes, we have many resonance structure. That meaning this is more stable. That meaning is this is the stronger acid. خلاص. أو قاعدة قانون. Okay? This is rule for you. Clear? Okay. Now, question. Anyone is more acidic than other? Alcohol and phenol, your answer will be to write the conjugated base, make a resonance structure, to write the resonance structure, and compare the stability. Anyone is more stable, it will be more acidic, and you have to take the answer from here, okay? Physical properties. Okay, the physical properties of the phenol. What he said here, they say the physical properties of phenol are strongly influenced by the hydroxyl group. Yes, the hydroxyl group of the phenol is the functional group. It will be effect in the reactions and the physical properties, which is this phenol from the hydrogen bond with other phenol molecules. Okay, that meaning we have hydrogen bond. If you have phenol like that, this is phenol. For example, this is phenol. For the hydrogen bond, I will write it by like that. Okay? This unshapeable electron on the oxygen can make hydrogen bond with other phenol molecules. Okay, this is the hydrogen bond. This is the meaning here. Okay? This is the hydrogen bond. Okay. Which phenols? Okay. And with water also, he can be make hydrogen bond the same system with what? With water. If you have water, also here can be hydrogen bond with what? With the hydrogen here. Okay. With water. Okay, can be make hydrogen bond with water. So, does the phenol have higher melting point and boiling point and are more soluble in water than arenes? Arenes يعني what meaning arenes? Arenes is the aromatic compound. Okay, that meaning than aromatic compound. Okay, than what? مثلا than benzene, than naphthalene, like okay. So, and aryl halide. If you have to compare between of them. So, you have like toluene here, other toluene benzene with the CH3. And here, phenol. And here, aryl halide. This is the aryl halide. Okay. Compare, look to the molecular weight. The same molecular weight. Okay, slightly different between the molecular weight. Okay. Look to the melting point. This is minus 95. Okay, look to the phenol. 43. Look, it is higher melting point than the toluene. Okay, look to the fluoropenzene. Okay, it is minus 41. Okay, look to the boiling point 111, 132, and 85. Why this has higher boiling point than arenes and aryl halide? Why? Because the hydrogen bond. Okay, because the OH. Okay, in your exam, don't say because the hydroxyl group. Okay, because the hydrogen bond for the hydroxyl group. It will be complete answer. Okay. So, this. Okay, the phenol, soluble in water or not soluble in water? Soluble in water. Why soluble in water? Because the hydrogen bond can be make hydrogen bond with the H2O molecules and it will be soluble in water. Okay? Look, until now we just take general information, okay? There is nothing difficult until now. Okay, so the phenol chapter, in my opinion, it is easy chapter. Okay? It is easy chapter. Okay. Some ortho-substituted phenol, look to the ortho, such as orthonitrophenol, AVA, orthonitrophenol, have significantly lower boiling point than those has meta and para derivative. Okay, meta and para derivative. So the meta derivative, I will write it for here. This, for example, you have it. Okay, anyone this nitro and phenol, I will write here phenol. This is the phenol, and this is what? NO2, nitro. This is the nitro, okay? The nitro, you know the nitro is what? If I want to write it complete, this will be minus on the oxygen and positive on the nitrogen. And look, here we can make hydrogen bond between this oxygen minus and this hydrogen. No, there is no hydrogen bond between this and this. Why? Because the distance is so far to make the hydrogen bond between this and this. Okay? The same thing here if you have the meta. Here, I will write or minus here, as you want, minus here. Okay, it's the best. And here. Okay, we can make hydrogen bond between this and this. Also, no, it is so far distance between two groups. Okay, but if you go to the ortho derivative, this is the ortho derivative. Okay, the distance here is typically can be make hydrogen bond between this oxygen and this hydrogen. So, in your opinion, if you think anyone has higher boiling point, melting point than other, the ortho derivative or meta para? Meta para. Why? Because the meta para, it will be make hydrogen bond with other molecular of the same compound. Okay? For this reason, يعني, I will write it for you here. This, it will be make hydrogen bond with the oxygen minus, sorry, for the nitrogen. For the another molecule here and OH. Okay, now we have hydrogen bond here between the two molecules. We say intermolecular forces. Okay, inter-hydrogen bond. Okay, inter-hydrogen bond. So, but this compound, the hydrogen bond is actually intra-hydrogen bond, intra-molecular forces for the same compound. So here we need energy to break down this hydrogen bond and to convert the molecule from the liquid state to the gas state. But here we don't need it to break down this hydrogen bond. Okay, so anyone has or anyone need more energy for melting point or boiling point, this or this, the intermolecular forces. Okay, the intermolecular forces, it will be effect to the boiling point and melting point, but the intra-hydrogen bond cannot. Look, this intramolecular hydrogen bond. It will be not effect for that. Why? Because this is molecule alone. In the liquid state has hydrogen bond, intra-hydrogen bond. In the gas state also has intra-hydrogen bond. This hydrogen bond is not between two molecules. It's for the same molecule. Okay, for the same molecules. For this reason, diamond, meta or para derivative has higher melting point, boiling point than ortho derivative. Okay, not for all compound. For some compound that has intramolecular hydrogen bond. Okay, like this compound. دائما منو الانترا دائما. Okay, so for some compound, for some molecules, not for all compounds. Okay. يعني if I give you example here, مثلا this, for example this, بلا OH, تمام؟ OH. Okay, this OH, and here we have CH3. Okay, this OH we have CH3. This OH we have CH3. Do you think we have big difference between boiling point and melting point for this compound? Big difference between ortho, meta, or para derivative? Okay. This can be make hydrogen bond with this? No. 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 Because what? The condition of the hydrogen bond is what? Is what? Is hydrogen bond. Anshap of electron on the oxygen, nitrogen, or I. Okay. It will be make what? Make attraction with Chia? With acidic hydrogen. That meaning we have hydrogen, you must have hydrogen partially what? Partially positive. This hydrogen here is partially positive? No. So we don't have hydrogen bond here. Okay. For this reason, if you want to know there is different or not between the melting point of this derivative, I think there is no different. Okay, there is no different. Maybe just a slightly different. Okay, not big different of the melting point and boiling point. Do you understand? So here problem for you. He said one of the hydroxybenzoic acid is known as common name of the salicylic acid. Salicylic acid common name is methyl ester. Methyl ester. Okay, methyl salicylate. Occur in oil. Okay, this is general information. Methyl salicylic boil over 50 degrees, lower than either of the other two methyl hydroxybenzoate. Okay, more than other two derivatives. It is the idea like this, like here. Okay, so I give you the idea here. Okay, so what is the structure of methyl salicylate? Number one. Okay, and why is its boiling point so much lower than other? It is rigoisomers. Okay, rigoisomers yani other isomers like this. This is the rigoisomers. Okay, okay, you have to think and resolve. Easy, not difficult, but you have to try to resolve in your home and solve the answer. Okay, but it will be coming from here. This is what? Acidic acid, carboxylic acid. How I convert this to the ester? What I have to change? Ester. I have to change the hydrogen with alkyl group. Just change the hydrogen with alkyl group. It will be methyl salicylate. This is the idea. Okay, it will be methyl salicylate. And he said, why methyl salicylate is lower boiling point, melting point than other isomers. Also because the answer will be what? Because the enter hydrogen bond for the other isomers. Okay, this has what? Has intra hydrogen bond, and the other there is no intra hydrogen bond. There is inter hydrogen bond, and the difference will be coming from here. Okay, write your answer, and will be so. So the acidity of phenol, as I explained for you before that. The phenol is more acidic than alcohol. Why? Because the stability of what? Of the conjugated base. Look, this is the phenol. This alcohol. It will be converted to the conjugated base by reaction with the acid. Remove a proton by reaction with the base, and remove a proton to give you the conjugated base. And this is the phenol. This is the conjugated base. Anyone is more stable, this or this? Of course, this it will be more stable conjugated base because the resonance structure. Okay? Because the negative charge on the oxygen, it will be stabilized by the resonance structure by the resonance over benzene ring. Okay, over benzene ring. So, here the same resonance structure. Just explain for you. So, I think here the good idea here in this part, he said to place the acidity of phenol in perspective, not that also the phenol is more than million times more acidic than ethanol. Okay? Anyone? Phenol more acidic than ethanol. Okay. So, I say it is over 100,000 times weaker than acetic acid. Okay. Anyone is more acidic? The acetic acid or phenol? Acetic acid. Why? Why? A carboxylic acid is more acidic than phenols. Why? Why? You know the answer. I know you know it. Why? Step number 1. Conjugated base. Conjugated base, what we have in the carboxylic acid? We have 2 resonance structure. Okay, the negative charge on the oxygen, negative charge on the oxygen. Okay, the negative charge on the 2 oxygen. Anyone is the more stable. You have negative charge on the 2 oxygen atom or negative charge on the oxygen and carbon? Oxygen atom, of course, oxygen atom. For this reason, the conjugated base for the carboxylic acid, I will give you in the next slide, it will be more stable than phenols. Okay, than phenols. So, for this reason, he said the phenols is weaker than acetic acid, than carboxylic acid. Okay. Thus, phenol can be separated from alcohol. If you have phenol alcohol, okay, with together in the same round, phenol alcohol, you can separate it of them, the ethanol from phenol, okay, from phenol by using these properties, the acidity, the different acidity between of them, by using the solubility. I will explain for you. Okay. So phenol can be separated from alcohol because they are more what? More acidic, and form carboxylic acid because they are less acidic. Okay. On shaking an ether solution, if you have ether solution round like that. Okay. You can apply this in your lab, okay? If you have conical, and this conical has what? Ether solution, okay, ether solvent, okay. This ether solvent, what you have inside the ether solvent? Okay, on shaking the ether solution containing both what? Alcohol and phenol. For like what alcohol? Like CH3OH, phenol. This phenol, this is together, one layer together. Okay, one layer. If I say to you how you can separate it, phenol from alcohol, okay, how you can separate it, ether of alcohol. This question for you by using the different acidity between of them. Okay, that meaning by reaction with what? By reaction with what? With base. Okay, I will add base to the conical. Okay, to this solution, I will add base to this solution and see. But any base, this is the important. Any base you have to use. Any base you have to use. So, alcohol is weak acid. Phenol stronger acid than alcohol. Okay, that meaning you need to use strong base, but in what? We said in low concentration. Okay, strong base, but in low concentration. For this reason, I will tell you here. Where is it? Here. The phenol is converted quantitatively to it is sodium salt. Okay. If you use, for example, NaOH. Okay, NaOH. Alcohol, this alcohol, OH plus NaOH, no reaction. Or if we have reaction, this here, it will be more stable than this side. Okay, for this reason we said no reaction. Okay, the equilibrium it will be for this sides. Okay, if you write all complete question. Okay, so if you have phenol like this phenol, and you have NaOH, directly it will be react with the phenol, and the OH minus, it will be attack the proton and give you phenoxide anion, this minus on the oxygen, and this, look to the equilibrium, anyone is more stable. Oxygen minus, and you have here resonance structure, or oxygen minus on the hydroxyl group, anyone is more stable? This is more stable. For this reason, look to the arrow, to the equilibrium, it will be toward this side. Okay, that meaning the reaction will be happened. And the phenol, it will be converted to the phenoxide anion. طبعا O minus with Na positive. ملحة, salt. Okay, salt. Okay, the salt is soluble in water or not soluble in water? خلاص, soluble in water. Okay, this the base زائدا H2O. For example, مثلا one normal NaOH. What meaning one normal NaOH? يعني NaOH with the water. So you have to put base with the water. That meaning we have two layer, and then we have what? Water. Okay. This the H2O with what? H2O with phenoxide anion. This is the phenoxide ion. O minus Na. This the ether with what? With kahol. Okay. All the phenol convert to the salt. Okay, that meaning with what? With kahol, CH3OH. Then you have two layer. Okay, two layer is easy to separate it or not? Easy by what? By separating phenol. You have to use separating phenol and to separate the this two layer from each other. Okay, so if you have this layer, look, this layer, just after separation you have beaker. This is the beaker, and you have H2O with what? With phenoxide. Phenoxide. This is the phenoxide. Okay. Now, how I convert this to the phenol? How I convert this to the phenol? This salt form. شكل الملح. Okay. How I convert it to the phenol? By reaction with acid. Okay. Good. HCl. Put HCl. Put HCl here. Okay. Directly. This it will be what? It will be phenol. OH plus what? Plus NaCl. Okay, and you get the phenol. The alcohol is remain with the ether. خلاص. Finished. Okay. This is the good question for you. Okay, and you have to write note about this. Okay. Now, if you have, look, he said, on shaking an ether solution of phenol and carboxylic acid with diluted sodium bicarbonate. Now I will use sodium bicarbonate. Sodium bicarbonate, NaHCO3. Sodium bicarbonate is weaker base than what? Than NaOH. Okay. So if you have conical flask or beaker and you have two compounds, carboxylic acid and phenol, how you can separate it? The carboxylic acid from the phenol. This is the two types of separation. How you can separate the carboxylic acid from the phenol? By reaction with weak base. Okay, now the phenol is strong acid or weak acid? Weak acid. Can be react with weak base? No, cannot be react with the weak base. Okay? Okay, why cannot be react with the weak base? I will show it to you. Okay, now this weak acid. Okay, this weak acid, and this it will be weak or strong base. So, sorry, I said this is again. Sorry, this is weak base. Okay, this is weak base, and then we react with the phenol, give you this minus on the oxygen for the phenoxide anion. Anion is more stable. This or this? No, actually this is the more stable one. Okay, for this reason, the stability or the equilibrium, the lower equilibrium, it will be go to this side. Okay, look, this is this side. Yes, this here, the resonance, it will be over 3 oxygen atom. We have 3 oxygen atom here. But this, the minus, it will be on the oxygen and the carbon. Okay, for this reason, this it will be more stable. Conjugated base, and diamond the equilibrium will be go to this side. Okay, now if you have carboxylic acid, the carboxylic acid can be react with the weak base. Carboxylic acid, strong acid, can be react with the weak base. Yes, can be react. Easy can be react. Why? Because I said carboxylic acid is strong acid. Can be react with weak base. Okay, can be react with weak bases, and by using this difference, you can separate the carboxylic acid from the phenol. Okay, you can separate the carboxylic acid from the phenol. So if you have here like this carboxylic acid, I don't give you the equation here. CH3, this carboxylic acid, okay? And NaHCO, sodium bicarbonate, okay? Sodium bicarbonate. The reaction here, it will be easy to remove this, okay? Remove a proton from the carboxylic acid to give you, for example, this. Oxygen minus plus what? Plus H2CO3. Okay. H2CO3. This directly give you this. Okay? Directly give you this. For this reason, we can separate the phenol from the carboxylic acid by using bicarbonate, sodium bicarbonate, potassium bicarbonate, sodium bicarbonate. المهم weak base, by using weak base. Okay. It is necessary to keep the acidity of phenol in mind when we discuss the preparation and reaction. Diamond, if you have, when you talk about the preparation of phenol or reaction of phenol, diamond you have to keep the acidity of the phenol in your mind. Okay? Okay, acidity, خطوة, the final step, it is salt, is acid, is base form. Okay, you have to think about that. Okay, it's so important. So, reaction that produce phenol, reaction give you phenol like this, give you phenol, when carry out in base solution, okay, if your condition, if your medium is basic, diamond required what? Required acidification. Okay, it is like this step here, I write it before that. You said we need acidification with HCl to convert the phenoxide anion to the phenol. Okay? Diamond, you need acidification step. Why the acidification step? In order to convert the phenoxide anion to the neutral form. Okay? To the neutral form. يعني to the phenol. To the neutral form of the phenol. واضح؟ ايه separation by reaction with the okay, the same idea look, the same idea يعني if you have conical if you have conical and you have solution of ether مثلا by using ether solvent plus carboxylic acid. What كي جاي carboxylic acid مثلا benzoic acid, هذا benzoic acid. CO2H plus what? Plus phenol. This is your question, okay? This is about what you talked about it. If you have phenol and carboxylic acid, how we can separate of them? Okay? Put what? Put solution of H2O. When we say solution of sodium bicarbonate, يعني NaHCO3, يعني sodium bicarbonate in water. Okay, this is the solution of sodium bicarbonate to the mixture of two components, and see what will be happened. What will be happened? This and this, it will be react with the sodium bicarbonate. Anyone? Phenol can be react with sodium bicarbonate? We said no, cannot be react. Why? Because this weak acid and this weak base, there is no reaction between of them. Okay, but this strong acid or this weak base, the reaction will be happen. Okay, the reaction will be had, and the carboxylic acid, it will be converted to what? To the salt form. Okay, to the salt form, as I write it here. Okay, to the salt form. Diamond this with the HCO3 minus, it will be directly converted to the salt form. CO2 minus Na plus H2CO3. Tamam. This is, it will be salt. Dissolved in water or not dissolved in water? Dissolved in water. That meaning after that, you will have two layers. Okay? H2O layer and ether layer. aqueous layer or an aqueous layer. Okay, the salt, it will be go to the aqueous layer and use what? Separating funnel to separate the two layers from each other. And then what? How you can convert to this to the acid form? By using what? Acidification. Okay, by using acidification. HCl, H2SO4, and it will be come back to the carboxylic acid again. Okay, this is the procedure. Okay, substituent effect on the acidity of phenol. طبعا it is not a new subject for you, it is old subject. You take it in organic chemistry, stage number 2. So the substituent here, what we take? Phenol, we said phenol without substituent. Glycerol, كيف substituent يعني glycerol؟ يعني CH3 هي CH3. Okay. Chlorophenol, halogen, yes. And methoxy, what meaning methoxy? Any substituent methoxy? Do you know? Methoxy يعني CH3O bonded. This is the methoxy group. CH3O. Okay? CH3O is the methoxy group. And nitro group. Look, this is the pKa. The pKa diamond, when the pKa low, that meaning it's stronger acid. You know this, yes? pKa low. Okay. Look, to the phenol, 10. And the glycerol, we have difference between the numbers? 10, 10, 10, 10. No, that meaning CH3 cannot be affected to the acidity of the phenols. Okay? Why? CH3 donating or withdrawing? Donating or withdrawing? Donating. By an effect, resonance on inductive effect. Inductive. Resonance أصلا نينا. Okay? Then, donating, look to the number is more than 10. More than 10. يعني it will be weaker acid than phenol itself. Okay? Weaker acid. The idea is coming from here. I will give you the idea again. Look. Okay. This, the OH. Tamam? OH. What we have here? We have bond. Okay. When I say to you, it will be more acid or less acid, we talked about what? About the stability of the conjugated base, yes? Then the conjugated base, this is the conjugated base, our conjugated base. That we have minus on the oxygen, and electron density on the oxygen. So, if you have a group donating, this group donating, that meaning it will be increase or decrease the electron density on the oxygen, donating, increase the electron density. Then increase, it will be less stable or more stable? Increase the electron density, it will be less stable. That meaning it will be weaker acid. For this reason, look to this number, is higher than 10. Yani weaker acid than phenol itself. So, I will change it. If you use a group, this group is withdrawing. That meaning it will be decrease or increase the electron density on the oxygen. Decrease the electron density. Okay. That meaning it will be increase the stability, decrease the stability. Increase the stability. That meaning it will be more acid. Look to the nitro. How much? 7.2. That meaning is more acid than phenol itself. Okay? This is the effect of the substituent. This is our subject. Substituent effect. Okay? The effect of substituent on the acidity of the compounds. Not just the phenol. You remember on the carboxylic acid, we talk about the carboxylic acid, about alcohols. Okay? Okay, what's your question? Nitro? Why? Because diamond nitro is withdrawing group. Okay? Then withdrawing by any effect, do you know? By any effect? The inductive higher or resonance? Withdrawing by both of them. By inductive or by resonance. Tamam? Both of them to be reinforce each other. Hardu withdrawing. In O2 تأثيرية يعني قوية. Okay? Okay. on the nitro, look to the nitro. We talk about the nitro. We have ortho, meta, para. Okay. Look to the ortho, 7.2. Look to the meta, 8.4. Look to the ortho, para, 7.2. Anyone is more acidic? Ortho, meta, para, anyone? Ortho, para. Meta is lower acid than ortho. Why? Why? This is the question. Okay? If I give you a question in your exam, why the ortho, para, nitro, phenols derivative is more acidic than meta? Why? Yes, all of them has negative charge, but this here, yes, the stability of the conjugated base because the resonance. Okay, I will give you. You have to write the resonance structure. So, Jawab here. I will give you here. Meta nitro group is not directly conjugated to the phenoxide oxygen and thus stabilize أو جوابه. Okay, stabilize the phenoxide in it to the smaller extent. Okay, for this reason. But in the meta nitrophenol is more acidic than phenol, but less acidic than other orthopara, the orthopara nitrophenol. Why? Because here the stability of the conjugated base, the effect of the resonance. Okay. Now this is ortho or meta or para derivative. This is ortho derivative. Okay. I will remove the proton. It will give you minus on the oxygen. This minus on the oxygen, it will be stabilized resonance with the nitro group or not resonance with the nitro group. If you write it here, this make pi bond, and this it will be open to here. Okay. That meaning it will be go with the resonance structure with the nitro group. Okay. And give you 2 minus on the oxygen. Okay. Look, minus on the oxygen, minus on the oxygen. Okay. Look to the para, also the para. Make pi bond, and this will be converted here, and this it will be converted to make pi bond between carbon and nitrogen, and this here it will be open to the oxygen to be give you minus and minus on the oxygen atom. Minus on the oxygen, minus on the oxygen. I will give you the meter. This is the meter. Okay. Look to me. This is the meter like that. Okay. This is the meta nitrophenol. Meta nitrophenol. Okay. Remove a proton by base. We give you oxygen, oxygen minus. Okay. Oxygen minus. Oxygen minus make pi bond between, and this it will be open to here, and this it will be open to here. Okay. This can be go to the resonance with the nitro group? No, there is no resonance with the nitro group. Nitro group cannot be entered to the resonance like orthoparas. Look, like orthopara. Okay? Cannot be. Cannot be. If you write it here by 2 step, this is 1 step. By 2 step, it will be like that. This, it will be minus here. Okay, minus here. This is the minus. Okay. This is the minus. And what he have? This. Like that. Okay. Now, I can make this negative charge. Can we make here pi bond? No, it is impossible. How? Yalla, convert this. Khalas. This it will be open to here. Okay? That meaning here the nitro group cannot be entered with the resonance structure. Okay? For this reason, anyone is more stable. Anyone is more stable. Negative on the oxygen or just carbon, or on the oxygen like that. Other oxygen. Anyone is more stable? Oxygen. For this reason, it will be give you stronger acid than meta. Meta. Tamam? Clear? Okay. So, this is homework problem for you, but maybe a resolved problem. Okay? Maybe I will take half hour addition to this lecture, okay? Because I repeated the subject. So, This is homework for you, problem for you. He said, which is stronger acid in each of the following pairs? Explain your reasons. Okay? Anyone? This phenol or para-hydroxybenzaldehyde? Okay, you know the benzaldehyde. Okay, you know the benzaldehyde because you took the benzaldehyde before that. So anyone is more acidic than other? Meta-cyanophenol or para-cyanophenol? Okay, this for you. طبعا I give you here just the idea for the solution and you have to write the answer. Okay. Also, this is resolved a problem. He said rank the following compound in order and increase acidity. This type of question is important and you can write it not here. This is resolve the problem. أو حلوية, okay? You can take the resolve. This homework for you. Which phenol in each of the following pairs is more acidic? Okay, justify your choice. You have to choose anyone is more acidic than other. This or this, this or this, this or this, like that. Okay. Also this, rank the following compound. I give you here many homework. Okay. Preparation of phenol. Preparation of phenols. Look, maybe we have reaction with the mechanism, maybe without mechanism, but I will write it for you, the mechanism, if I wanted to give you the mechanism. So, like here, any reaction this is related with any addition elimination mechanism. This is a new mechanism for you. For this reason, I will give you the mechanism for this reaction. So the reaction of benzene sulfonic acid with sodium hydroxide طبعا precede by addition elimination mechanism of the nucleophile aromatic substitution. Okay, now our mechanism is what? Addition elimination. يعني you have to addition and then elimination. أو خطوة مهمة. You have two types. You have elimination addition and you have addition elimination. Okay? So here is addition elimination mechanism. For what? For nucleophilic aromatic substitution. I think you know the electrophilic aromatic substitution. Okay? Electrophilic aromatic substitution. Any type of reaction. Do you remember? Acylation, alkylation, bromination, nitration, sulfonation. All this is what? Is electrophilic aromatic substitution. Do you remember? Yes. Okay. This is not. Is what? Is nucleophile aromatic substitution. فرقة. There is different. Okay. There is big difference between nucleophile aromatic substitution and electrophile aromatic substitution. So, look, hydroxide replace sulfide anion. This is the SO3 minus 2 sulfide anion at carbon at that pairs the leaving group. Okay, so this is sulfonyl group. Sulfonyl group, acid or base? Acid. Of course, acid, strong acid. Okay, sulfonyl group. And what is here? You have to the first step. You have base. Look, KOH, NaOH, and you have 330 degree heating, high heating. For this reason, you have here base and you have here acid. Okay, that meaning the reaction will be happen between base and acid. Proton, it will be this proton donor from the base. And then the addition mechanism will be happen. The addition mechanism, it will be happen. It will be happened, okay, the addition will be happened here or here or here or here or here or here. No, at the same carbon that has leaving group. Okay, any group is changed, look to the reaction. Any group is changed. This is CH3 or this is sulfonyl group? Sulfonyl group. That meaning the addition will be happened on this carbon. أو مهمة. تمام؟ أو قلق مهمة. At the same carbon that has what? The leaving group. Okay? You have put here, where is the leaving group? أو leaving group. وصل. Put 2-3 lines. أو مهمة. Okay? أو مهمة. So, what he said, if you have like this reaction, this reaction, look to the second step. Second step, why? What is the second step? acidification base or acid? Acid. يعني protonation, as you said. Protonation. Okay, protonation. Why? We said, be careful, be careful. If you have reaction or preparation of phenol compound and you have in basic medium, you have to be careful about phenoxide anion. دائما you have to use acidification step. Okay, أو acidification step أو قلق مهمة. تمام? It is so important. So important. Why? To take the phenol compound. ب أو خطوة without acidification step, there is no phenol. There is phenoxide, salt, ملحة. Okay? Salt, ملحة. For this reason, be careful about this point. So, write a stepwise mechanism for the conversion of the para-toluene sulfonyl acid to the para-glycerol under the condition of the here that put it here. Okay, I will give you the mechanism. This is the mechanism. Okay. First step, diamond. You have base and you have acid group. The base take a proton. Tamam? The base take a proton and give you oxygen minus. Oxygen minus. Now this is what this is leaving group. وصل. إشارة دانا leaving group أو leaving group أو leaving group هذا leaving group. تمام? Leaving group. Now after a reaction يعني acid base reaction happened, what we have our mechanism is what? Is addition, elimination. يلا addition. Look, OH it will be add to this carbon and this pi bond it will be give open to make minus on the carbon. Oh, minus on the carbon. This minus on the carbon. That meaning addition of the hydroxyl group on the benzene ring. Then this minus is stable by resonance structure or not stable by resonance structure? Yes, stable. We have 3 resonance structure. 1, 2, 3. أو وصل بنبيسها أو 3 resonance structure. صح كسهم فرقة. This is resonance arrow. Okay. This 2 heads arrow. أو فرقة. That meaning this is resonance structure. Our resonance structure. Our reaction number 1, reaction number 2, resonance structure, reaction. Okay. Now addition of the hydroxyl group and resonance structure. So this is the leaving group. When the minus make pi bond here, this the leaving group it will be leave the structure and give you the phenol. Okay, and give you the phenol. تمام? Step number 2, our phenol tahir. You have phenol now, but our medium is what? Acidic or basic? Base. Then the reaction will be happened between your product and the base or not? Yes, it will be happened, of course. It will be take a proton from the OH, give you phenoxide anion. Then phenoxide anion, how it will be converted to the phenol again? By acidification. Add acid, خلاص, your phenol compound. تمام? Okay, يعني acid base reaction, deprotonation, addition, resonance structure, elimination, and final step, this is the acidification. خلاص, this is the mechanism. يعني easy mechanism, not so complex. تمام? Okay? Do you have a question? Anything it is not clear for you here? أخير شو صار? Your product is phenol, yes? Phenol can be react with strong base or cannot be react. The conical higher. The phenol, your medium is what? Is basic medium. Can be react or not can be react? Yes, can be react. Can be react to give you phenoxide anion. The phenoxide anion, the salt, how it will be converted to the phenol again? By using acidification. Okay? You have to use acidification. You have to use, and this step here, I will talk it. Yeah. Step number 2 is what? Acidification. Our step number 2 is here. Is here. Okay? So, this homework for you. طبعا this Q barcode for the channel, YouTube channel. تمام? Okay. The base bromide hydrolysis in chloropenzene proceed by the elimination addition. Look here is elimination addition mechanism. What? Elimination addition mechanism and involve benzene as intermediate. look to the benzene. benzene يعني وكي الكان يعني شي هيابة يعني double bond and triple bond. triple bond. Okay, 3 bond. وبنزين benzene يعني benzene with a triple bond. Okay, benzene with a triple bond. Where is it like that? Benzene. Benzene بس triple bond that has it. Okay, for this reason they say benzene. Okay, but our mechanism is what? Is elimination, addition. Not like the first mechanism, addition, elimination. بالعكس, elimination, addition. Okay. طبعا, this is the mechanism. I will give you details, information about this mechanism, but not in this slide. In the maybe next few slide letters. Okay. So, a problem here. He said, hydrolysis. The hydrolysis of chloropenzene. What meaning now? The hydrolysis. Hydrolysis. Reaction with water. Diamond in an acid medium or basic medium. Here we use basic medium. Come on. Look. NaOH, H2O. Hydrolysis reaction with water and base in basic medium. Okay. So, write stepwise mechanism for the hydrolysis of chloropenzene under what? Under the condition that's shown here. Under this condition. Okay? Step number 1. OH minus, take a proton. خطوة نووية. This step is elimination. Okay? Elimination. Take a proton. And this bond between hydrogen and carbon make additional pi bond, and this it will be leave the structure as leaving group. The chlor here is leaving to give you the benzene. This is the benzene. Okay, benzene. Now, addition, elimination step finished. Addition, the OH it will be add, and in this carbon or in this carbon. Okay, and 50 to 50. This 50%. It will be can be attacked to this side, and 50% can be attacked to this side. Okay, no difference between of them, this and this. But if you have substituent here, it will be different. Okay, we talk it about that later. Okay, addition it will be give you carb anion. This it will be add, and this it will be pi bond. It will be open to give you minus on the carbon. Now minus on the carbon, it will be take a proton from the water. Okay, take a proton from the water. For this reason, we say hydrolysis. Hydrolysis is a reaction with water in basic medium. Okay, it will be take a proton from the water and give you phenol. Then our medium is acidic or basic? Basic. That means phenol can be react with base or not? Can be. To give you what? Phenoxide anion. Then phenoxide anion, the oxygen minus. How we can be convert to the acid form again? By acidification. Okay, by using acidification. Okay, دائما all times remember the acidification step أو مهمة all the times. Okay, the most widely used industrial synthesis of phenol is based on the isopropyl benzene, the cumene, نبي cumina. Okay, cumina أو cumina أو structure of the cumene. Isopropyl benzene. Now, very common name for the isopropyl benzene is cumene. Okay? بس أو industrial, يعني not in the lab. Industrial procedures. Okay? So, the isopropyl benzene, the cumene can be react with the oxygen to give you peroxide form. This is the peroxide form. Peroxide, it is like peroxide hydrogen. This. H2 O2 peroxide, hydrogen peroxide. Okay, hydrogen peroxide. Alkyl, oxygen, alkyl, hydrogen, oxygen, hydrogen. Okay, like this. For like this, look, hydrogen, oxygen, alkyl. This is the peroxide compound. This is the functional group for the peroxide compound. You have ROOR. Tamam? Okay, to give you the peroxide carbon compound, peroxide compound. This is the hydrogen peroxide can be react with the H2 in acidic medium. Okay, why we react with the H2SO4 to give you the phenol and the acetone. And both of the phenol acetone is important in the industrial line, in the laboratory line, and any lines. Okay, acetone, you know, acetone can be used as solvents. It's so important. Also, the phenol compound can be used in organic synthesis, as you know. Come on. So we have mechanism, no mechanism here. I just take that reaction. No mechanism, just the reaction. Tamam? Number 4, the preparation of the phenol. The most important synthesis of phenol in the laboratory is from the amine. This related with chapter number 1, the amine, diazonium salt. We have the diazonium salts can be formed from the amine compound, from the aromatic amines, is related with the amines by hydrolysis to the corresponding diazonium salts. For this reason, if you have this meta-nitroaniline, this is the meta-nitroaniline, okay, it will be react with NO2, H2SO4, H2. This it will be give you first step, give you diazonium salts, and diazonium salts can be react with water and heating to convert the diazonium salts to the OH. This is related with the amines. Okay. Also, we have, I think we have the mechanism in the first chapter with the chapter related with the amines. Okay. Just I will give you the idea here. For this compound, if you have NO2 and or meta, like this example, exactly like this example, on meta, NO2, directly this can be react with what? With NO2, H2SO4, تمام. طبعا aqueous medium. Okay, this directly to convert to the diazonium salt. This is the diazonium salt. Okay, diazonium salt. So this diazonium salt easy convert to the many compound. If you want the OH group, directly react with the H2O and heating to convert to the mechanism. Yes, you have the mechanism, and you can go back to the amines chapter. We have details mechanism there. Okay? I don't repeat it here. Okay, no problem. But easy mechanism, not you have natrosium salt ion, it will be react directly, and easy mechanism, not so difficult. Yalla, the mechanism, homework for you. Okay, for you. Write the mechanism for this reaction with the homework. Tamam? A cleavage of aryl ether by hydrogen halides. Okay? By hydrogen halide. This is your subject in the last year. Okay? This is your subject in the last year. If you have ethers, and the ether, it will be react with what? With the acids. React with the acids, and by two mechanisms, or SN1 or SN2, depending on the structure of the ether. Okay? For if you have like this ether, for example, this is the ether. Okay? I said to you the first step, this it will be react مثلا with HBr. Okay. Where is the reaction? It will be happened? You have two unshapered ketone. It will be take proton from the acid to give you what? To give you this compound. To give you this compound and positive on the oxygen. Now this you have plus what? Plus Br minus. Okay. Br minus, it will be attack here, and this it will be open, it will be breakdown, and give you what? Give you alcohol. give you alcohol plus alkyl halide. This alkyl halide. Okay, this alkyl halide. And also this, it will be react with another molecule HBr and also give you 2 alkyl halide and H2O. Do you remember? So, if you don't use like this aliphatic ether, if you use aromatic ether, if you use aliphatic ether, it will give you 2 alkyl halides, okay? 2 alkyl halide and water. If you use aromatic ether, it will give you what? Phenol and alkyl halide. Phenol and alkyl halide. Okay. The mechanism not مطلوبة, but I will give you one example about this. يلا. This is what? What is the name of this compound? Do you know? What is the name? Yalla, give me a opaque name. Ether. Ether. Eh? No. Phenyl. Phenyl. Methyl. Ether. Okay? Or methoxy. Have a methoxybenzene. تمام methoxybenzene. يلا methoxybenzene with HBr. Okay? على السريع. أنشب في كترون عافية. Take proton. Give you this CH3 plus Br minus. Second step Br minus attack this CH3 and this it will be give you phenol compound. خلاص. أو mechanism. OH plus CH3 Br alkyl halide phenol. If you have used this, it will be give you alkyl halide phenol. Okay? This is the mechanism. بس not مطلوبة mechanism. Okay. Do you understand? Do you have a question answer here? Look, we are stopped in the slide 21 and we are here actually in the slide 22 from the for the chapter of phenols. تمام؟